Class, welcome to section 4 of Stanford Code in Place. We're going to be talking about images this week, and it's a great change from what we've been doing before because you'll really get a sense of how powerful Python can be and how easy it can be to do something as sophisticated as manipulating images. Now, I'll be upfront, this probably seems intimidating. It is a big topic to think, my gosh, I'm only 4 weeks into this, I'm going to be actually changing images, but it's not that bad. So you'll see. We're gonna walk you through it. So before I get started, I actually want to show you some great features that I found in Ed, which really should have been turned on by default. Most of us who ever used an IDE are used to having some features that are very important. So let me move this around here and then show you. If you click on the settings wheel here and you scroll down, there's a couple of things which are really important. Here's autocomplete. And here's linter. Autocomplete is going to give you a list of things that you can choose from, so that you don't have to worry about like having the wrong variable name or the wrong method name. And linter is going to be doing some basic syntax checking for you. So when I turn these on, it's now going to complain if there's a problem. So well, let's just walk through and we'll see. Okay, so the first problem they want to have me do this week, well, let me show you what all three of the problems are. So first, there's image filter. We've got this very simple image here. We want to convert it to this second image here. And what we're going to be doing is looking at every pixel here and looking for bright pixels. And when we find a bright pixel, we're going to modify it slightly. The two optional items, which I don't think we'll have time to get to all of them, but one is to take an image like this and actually trim it around the edges so that it loses a border. And then the opposite function is to take an image like this and put a border around it. So those are things we may not get to, but I'll at least talk about them. And I'll also be talking about the next assignment and what's in that. Okay, so let's start with image filter. And before I even really talk about how to solve this problem, let's just do some basic image processing. So the first thing you notice is that there's this function, simple image, and simple image will load a file name, in this case images/simba_sq, and I'll show you how to access that. Where is this images? So if you open up this thing here, there's an images folder and there's Simba. And if you want to do your own image, you can. You can just do a plus here and upload it. It by default uploads it outside the images directory, but you can just drag and drop it in if you want. So let's just see how we can process these images. So it's very simple. All you got to do is this image consists of millions of little pixels. Each dot that's in this image is what we call a pixel. And so we're going to create a variable name called pixel that will represent each of those little dots one at a time. And the way it's going to scan it is it's going, well, let's set up for a loop here. For pixel in image. Now normally, we have done range something, and that just counts a simple number. And what range is it's a function that enumerates a bunch of numbers. But there are other things that will enumerate a bunch of things for us. And one of those things is this image here. So I'm going to say pixel in image. And image is a very sophisticated object, unlike just integers or something. Image is a class. It's got a whole bunch of methods on it. One of those methods tells it how to enumerate every single pixel in the image. And it's going to enumerate them left to right, top down. So for every pixel in the image, what can we do here? Well, I want to do something that you can immediately see the difference to know that it really worked. So let's try for every pixel. Let's do something to the pixels. So if I type pixel, which is the variable that we use, which is our loop variable here, and then I type dot, the autocomplete is now going to give us a number of options. It should. Oh, right. It's already complaining. Look at this. See that red thing? It says invalid syntax. That's because Java guy forgot to put his colon there. It takes a minute or so for that to come through. Let's see. Invalid syntax. Yeah. Okay, there it goes. It fixed that. And now it's saying invalid 6. Okay, so now I should be able to do this. Pixel dot. Come on, don't make me. Yeah, there we go. Thank you. So pixel dot, you can see there's a red. And if we scroll down farther, there should be a green. Oh, there it is. Red, green, and blue. So let's take the red there, and let's set the red to a value. Let's set it to 0. That's all we'll do. For each pixel in the image, we're going to take the red and we're going to take the red out of it. And at the end here, image, which I said again was a class, it has lots of methods, including how to enumerate. It also has a method called show, and that's going to put it up on the screen for us. So let's go ahead and run this. And you notice how it's very green or blue? That's because there's no more red in that image. So let's try something else. So that's red. Another thing that we could do is we could actually modify. Let's try putting a stripe right down the middle of this picture. I haven't tried this before, but hopefully this is going to work. So how can we figure out a stripe down the middle of the picture? Well, I happen to know this image is at least several hundred. Oh, actually, that's a great thing. Let's go ahead and show that. Let's print image is, and then let's put image dot, and then let's see what are the image. What I'm looking for is the number of pixels across. So if, there's a problem with white space before open paren. Oh, interesting. It's very picky. Okay, but now it should work. Image dot. Come on, don't make me a liar. Show it. Show yourself. Okay, for some reason it isn't working. I think it's still because there's an error here. And it's still complaining about white space before that. Print image dot width is image is blah pixels wide by, and then image dot, no, not going to do it, height pixels tall. Let's run that. Okay, so let's close that. And so it's 222 pixels wide by 222 pixels tall. Well, what if we put a line down the middle of it between pixels, let's say 100 and 120. So I'm going to put an if statement here. If pixel dot, and now, good, there is an x greater than or equal to 100 and pixel dot x is less than or equal to 120, then let's set the red dot equals the pixel dot green equals the pixel dot blue equals 0. And of course I forgot the colon there. And what is it? It's still complaining about line is too long. Okay, that's really picky. Let's go ahead and run that. All right, look, we got a line right down the middle of it. So that taught you a little bit about now it's interesting. It looks like it. Well, I won't go back and look, but we succeeded at putting a line down the middle of it. So that shows you how you can use the X. What about the Y? Well, let's try that. Since it's a square image, we can change the Y, and let's run it. Ooh, look right there. See, another horizontal line. So now we know how we can access where a pixel is in the map. There's another way that we can enumerate the pixels in this image. So let's just comment these lines out. All right, so we commented that out. So now we're going to try enumerating it by, let's loop through the rows and loop through the columns. And then for each of those, we'll just copy the same code that we had before. But let's show you a different way of doing this. So here we were enumerating all the pixels in the image. And another student asked a question, how is it that when you do this, that all the pixels are in one row? Because what happened to all the other rows? So it's only a row in concept. And I noticed I didn't say it was a row, but some students realize that it's become a one-dimensional array. Well, what happened to the other dimension? So it's just doing one row at a time. You don't actually see the second dimension. But now we're going to actually give you both dimensions here. So I'm going to say for row in, and now I have to do a range, an image.height. So image.height is that 220. We want a range from 0 to 219. So that's what this is going to give us. Now I'm going to loop through the columns. Oh, and I forgot my colon. For column in range image dot, so this is the width now. And notice that X and Y and row and column are actually reversed, right? So X in an image is actually the column, and Y is actually the row. And you know, you just got to remember that, because sometimes you're going to be talking about rows and columns, which naturally do rows before columns, and sometimes you're going to be talking about X and Y, in which case you have to do the columns before the rows. So just be careful about that. So we're going to do that, and now we're going to copy the same code that I had here. And so this was to put a stripe down the middle of the picture horizontally. Hey, maybe we could, I was thinking we could do it diagonally, but the line is going to be so thin, it's going to be really tricky to see it. So, well, let's just use the same code, just so you see the difference. Okay, pixel. We do have to get the pixel. So now I'm going to say pixel equals image dot. Good. Okay, so let's look at our options here, and I need to scroll this down. So here's a get pixel XY. Get pixel, and now we need X and Y. Remember what I was just telling you? Okay, so X, that is actually the column that we want. So we have to put column and then row. All right, now let's try this. Okay, there it is. So what is the difference in these two methods? You can either do a 4-pixel an image, or you can do a row and a column. Well, you really should use this one, this top one, first, if you can. The problem is you can't always. So in what cases can you not do that? Well, exactly what I showed you. So if you want to put a line down, do something with knowledge of what row or column you're on, then you're going to need to find out you're going to need that row and that column variable. Now, actually, you probably can actually get the pixel. Let's just, because right, there's a pixel dot X and there's a pixel dot Y. So you could reverse engineer it and figure out what row and column you're on. But generally, what you're trying to do is you're trying to walk down all the rows or all the columns, and you'll see that in this week's assignment. So that's why we loop through the individual rows and columns. And on the flip side, another reason to use this 4-pixel is because, as typical of all languages that have 4 each, it's a syntactic shortcut. So we didn't have to assign the pixel variable like we did down here. So that is another reason to go that way. Okay, the last thing I want to do is talk to you about functions. So last week in lecture you learned about functions, but we never actually used them. So now we're going to start using them. What I want to do is I want to create a function that is going to figure out the brightness of a pixel. So I will call it brightness, and it will take a pixel. So when you're passing these arguments, what does this word pixel here really mean? Does this word have something to do with the pixel that's up here? The answer is no. It's a completely separate variable. And that's confusing for some students when they start, because it's like, well, it's the same word. Why isn't it the same variable? I could call this foo or bar. It doesn't matter. But for programming ease, we try to make it something that's going to make sense. And what's going to make sense is this is a pixel. Now, oftentimes, there'll be like multiple pixels, in which case maybe I'll say source pixel and destination pixels or something like that. And we'll see that later this week as well. So I'm going to take a brightness, and I want to return... let's go ahead and put a comment. Return the brightness of a pixel, which, and let's make it the average brightness. So I'm going to say, oops, average brightness, which is, no, I don't want a function, which is the pixels R plus G plus B all divided by 3. And that double slash there, that means integer divide. So let's get into this. So average equals pixel.red plus pixel.green plus pixel.blue, integer divided by 3. Let's go and open that over here. And let's see, what is this complaining about? Trailing white space. Okay, that's fine. And this is local very average. So, and now the other thing that you need about returns or functions is you can return things. So we are going to return that average. So that gives us the average brightness of a pixel. And now what let's do is instead of using this, we'll say if average brightness of pixel is greater than, let's say, 100. Now we're going to black it out. Let's put that close, that colon there, and let's go ahead and run it. Should fix itself from those errors. Ooh, well, that's a very ugly looking picture, but everywhere where the picture used to be bright, it's now black. So it did work. All right, so now let's actually take a look at the function. So what they want us to do is, so a pixel can be represented by 3 integers, R, G, red, green, and blue, that range from 0 to 255. Why 255? Because 255 is the maximum value that you can store in 1 byte, or 8 bits of data, 2 to the 8th. So that's how computers have always used red, green, and blue. So the average is those 3 components added together divided by 3. And what we want to do in this filter is replace any bright pixels with a grayscale equivalent. So how does a bright pixel define? Let's go ahead and put this here as a constant. So bright, I don't know, call it bright. Sure, let's just call it bright. Equals brightness. A bright pixel is considered to be 60% of 255. Now, it actually says here it's 153, but this to me makes more sense because then I can easily see, oh, 60% of the maximum brightness. So now I can say if the brightness is greater than bright, and then what are we going to do? We are going to, so if it's a bright pixel, we're going to replace it with its grayscale equivalent. And a grayscale is setting each of its red, green, and blue components to be equal to its average component. Okay, so we can set it to the, we want to save it really. We can go ahead and call it again. Or I could have saved it. Let's just go ahead and do it, run it again. Ah, yes, okay, so that looks good. But let's go ahead and change that. So instead, what we really should have done, because this is going to compute it twice, and it's not likely that'll be optimized out. So we are going to say pixel average brightness equals this, and now I can take this computed value, use it once there, and use it once here. Let's run that again. There we go. Great. And let me take a second and load in a different image just so we can see that. Okay, so I just uploaded this rainier.jpg. So, oh, you know, I got to change it in the file here. Instead of Simba Square, let's go to Rainier. And I think it couldn't find the file. Oh, I misspelled it here. Let's try fixing that. Rename Now let's go back to okay, 640 by 480. Okay, so there's the original. Oh, actually, that is the. It's really hard to see. It didn't actually change that much. Let me try. Let me make it half as bright. There's a lot of bright pixels in here. There we go. There's so many bright pixels that it didn't really show up very well. So that just proves that it did work. Okay, so that's how we do image filter, and that's actually the only required problem for this section. So we have time, so let's go ahead and take a look at the optional problem. And just to review, what did we learn here? So first thing, we learned how to process images. There are two main ways that you can process images, getting the pixels out of them. Number one is you can use the for each loop, here 4 pixel in image. Second way is you can go by row and go by column, or you could call it for x in the width and for y in the height. You could do it either way. Doesn't really matter. But you do a doubly nested loop. And some of you may not be even familiar with doubly nested loops, and I went over that fast. But basically, inside the inner loop here, columns, it's going to go over a column, and the outer loop over the rows, that is what's going to be, it's going to be doing the first row first, and then the second row, and then the third row, and within each of these rows, that's where the column loop is going through. So that's a nested for loop. That may be the first time some of you have seen that. We talked about how you can do a get pixel. There's also a set pixel, you'll see that. How you can get the width and height of an image, how to calculate the average brightness, how to change the pixels values. Yeah, and there's a little bit of complication we may get to later as well. So that's what we learned from this one. So let's see what we can learn from the next one. So the nice thing about that one is that we weren't returning a new image. We were only working on one image. So now we're actually going to be returning a separate image. So we're going to have to actually create a separate image, and it's going to be of a different size, and it's going to have similar content. We're going to get the content from the original image, but it's not going to be the same. So this is the function trim crop image. So it takes two arguments, the original image and the trim size. In this case, the original image comes from opening up this images Carol here. And we have to put our code here. So let's think about what is it that we're going to do. And you know, a lot of this is new. It's even new from the last problem. So it's okay to be a bit confused how we go about this. So I know, and I will show you. So this is the image reference guide on what functions are available for images. So you can ignore some of the top of this stuff. You don't have to worry about how to do that. That was for last year. But here's the functionality. So we've already learned about how you can open a file name and you get an image back. And we've already learned about the for each loop. And we've already learned about the red, green pixel, red, green, blue. I think we looked at the pixel X and Y, and we've seen image.show, and we've seen image.height and width. Don't worry about enforcing a valid RGB. But here's what I was looking for. Simple image.blank. So simple image.blank creates a new image of a given width and height. So that's the function that we're going to be using. So we now know that we can create a new smaller image because we're going to be trimming it, we're going to be cropping it. And we have to fill in the pixels on this new image. And so how are you going to go about filling in the image, the pixels of this new image? Well, what have you learned so far? You've learned that you can do a for each loop over all the pixels in the image, right? So could we use that? Well, we have to think, if we get just this constant stream, this one big long iteration of all these pixels, how are we going to know which pixels to remove? We really need to know what the row and column is, right? And you recall that I just discussed, if you need the row and the column, then you have to do a nested for loop, right? So we're going to have a loop over the rows and a nested loop over the columns. And we already discussed how we can get the pixel. So we're going to get a pixel, and what are we going to do with that? Oh God, the autocomplete. Okay, this is why maybe autocomplete wasn't turned on by default, because it keeps. Oh gosh, it's doing it again. Like, don't do that. All right. So we're going to get a pixel at the row and the column. What are we going to do with that? So if I grab some random pixel out here, it's a certain row and column, and we know that if it's within the first, for example, trim size is 30 here. If it's trim size is 30, if it's within the first 30 rows or the last 30 rows, we don't want it. We know that we're actually going to start with the first pixel for this new image being row 30 from this image. So we know that we're going to iterate over rows and columns. The choice you have to make here is which image are you going to iterate over? Are you going to iterate over the source image or the destination image? It can be done either way. But let's think, and it's not that bad either way, but let's think about this for a second. So if I iterate over the rows and columns of the source image, I know that if it's in the first 30 rows or last 30 rows, I throw it away. If it's in the first 30 columns or last 30 columns, I throw it away. If it's otherwise, I'm going to copy that to the new image. Now, here's the second way of doing it. We instead iterate over this new image. We got exactly exactly the number of rows and columns that we want. We need to calculate for the first pixel that it's not taking it from row 0 of the original image. It's going to take it from row 30. And for the first column, it's not going to take it from column 0. It's going to take it from column 30. And I just do that. I just have to do that math on each row and column here. And notice when I get to the end, if I'm iterating over the destination, then when I get to the end, I no longer have to worry about the stuff that's to the right or to the bottom. And it's for that main reason, because I don't have to worry about what's to the right or the bottom, that I would probably suggest that you do it over the new item. So it's loop over the columns of new image. And this is going to be here of new image as well. Now, yeah, that autocomplete is starting to drive me crazy. So once we get the pixel at the row, the column, and the new image, now we have to calculate the source pixel. And the source pixel is, so the row source row is equal to, so the row, when I say row, that's the loop variable. Loop over column, loop over rows. Yeah, sorry. So it's going to be the row, which is the loop variable, minus the trim size. Yeah, that's driving me crazy. And now source call equals column minus trim size. I'm learning that if I don't want it to autocomplete, you just got to hit the space bar and you're fine. So that's the pseudocode for what needs to happen. So we're going to create the smaller image. We're going to loop over the rows and the columns. We're going to get each pixel. And actually, do we need to get each pixel? Yes, we do. We do need to get the pixel. Not the. Okay, so you know what? I was off by rows of new image and columns new image. Get the pixel at the row column of the old image. So once we've got the, let's go take a look here. What is it that we can use? So we have not yet used this function, image.setPixel, x, y, and pixel. So we need an x, a y, and a pixel. So that's a column, a row, and a pixel. So that's going to be the column. Column, row, Actually, we need to change this, right? Because the pixel, this pixel actually needs to be here. We need to get the pixel here. And I got confused over the looping there. So we're going to set the pixel at column row. And this also is column row because it's reversed. So we're going to get the pixel of the old image at the it's actually source column. Source row. And we're going to set the pixel at the column and row of, that's the new one, so we don't have to adjust that, to be the pixel. Let's call that source pixel. Okay, so I'm not actually going to go through the code for this one for you, but that is the overall setup. We have to create the smaller image, so then we're going to loop over that image by the rows and the columns. We calculate the this is really a comment. We're going to calculate the source row and the source column by subtracting off the border. Then we're going to get that pixel in the old image, and then we're going to set that pixel. So let's take a look. We've still got time. Let's take a look at the add border. And this one is a bit trickier. It seems like it would be the exact same code, but it's not quite. So in this case, we're going to be going from this image to a larger image. So it's similar in the sense that we're going to be creating a new image. Instead of it being smaller, it's actually going to be larger. And then we need to transfer the image from one to the other. And again, we have to think, can we get by just iterating for each pixel in the image? And the answer is no, because again, the row and the column matter. So we're going to need to do the row and the column just like we did last time. And we're going to, let's see. So we have to add a border. So, I mean, there's a couple of ways we could do this. You could create the new image and then blank out the entire image. And that is possibly the simplest thing to do. So you blank out the entire image black, and then you want to copy each pixel. Which way are you going to iterate? So if we iterate over the larger pixel, larger picture, then we have to worry about these things to trim or to skip. So it probably makes more sense to iterate over the old picture, and then for each pixel, you have to calculate where the destination pixel is. And so instead of subtracting that trim, we're now adding the border. And then we're going to do the same trick. We're just going to take that pixel and put it into the new place. So it's similar, but not quite the same. Looks like we have plenty of time, so I'm actually going to go back to trim crop. And let's go ahead and write this function. So let's grab the function. Actually, we don't need to grab it because we have autocomplete here. So we have a new image is equal to simple image dot blank width and height. So what is the new smaller image? That's going to be the image. Oh, so it's the original image. Original image dot width. Thank you, autocomplete. So width is okay, comma original image dot height. So that's going to create the new image. Now we're going to loop over the rows of the image. This is the new image. So I'm going to say I want to have the word new in this variable to distinguish whether it's for the new or the old. So the new row in range, and remember I'm using range because the height we need to have an iterable in there, something that's going to generate that full range. So this is going to take the we're going to loop over the rows in the new image. So it's, what's it called? Yeah, there it is, new image dot height. Okay, so over that for the new row, and then we're going to do for new call in range of new image dot width. So now we've got that, you know, and for just a second, I'm just going to type in pass, which will, it's like a no op. It's not going to do anything. I just want to actually verify that the new image is the size that we think it should be. So this creates new image, and then we need to, let's see, inputs, original trim, returns a new simple image. So we have to return it. So let's just go down here and return new image. Okay, it's a little bit hard to tell whether that's smaller or not. Yeah, I was hoping that'd be a little bit more conclusive, but it's not. That's because the image here. Let's make this hugely. Let's crop it 100 pixels. Didn't look right. So let's check, make sure what we're doing here. Okay, so we take the original image and the trim size. Oh yeah, I forgot. So we're going to subtract off the trim size. And now it's going to be a much smaller image. There we go. And that was the point of doing that testing, is to make sure that that was going to be working right. So let's reset the trim size to 30. Okay. Good example of why we test things as we go along. Okay, so now we can fill in this code. So we're going to calculate that source pixel. So the source row, and actually, you know where to put this? We could do this here, but it's actually better we move it up. I'm going to do that in a second. It's equal to row. It's actually new row minus. Okay, so as I said, this will work here, but this is actually being computed every single time we do a column. We don't need to do that. So let's go ahead and this comment is now really redundant because it's just showing us what we did there. So let's put that there. So that's the source row, and now we have the source column here. Okay, let's get rid of that. Okay, so we need the old image dot get pixel at XY, so that's the column, which is the source column, and then the source row. Isn't this great with the variables? So they actually say source, and so we know that that goes with the original. And then we need to save this here. And then we need to set the pixel. So there is the new image. There it is, new image dot set pixel at XY pixel. So that's again the column. And now this is the new column. And the new row. And then source pixel. We aren't going to modify that. Now let's check on a couple of errors here. Trailing white space, trailing white space, trailing white space. Yeah, ironically, it's the spaces I put in to avoid the autocomplete that it's complaining about. All right, let's just go ahead and run this. Okay, so we have bad pixel, get pixel bad coordinate, x minus 30, y minus 30, and the image height is 188. So I remember the image was 220 by 220. It should actually, it didn't print out, but it's one. So 220 minus 30 is 190. So it's saying that the x coordinate is negative 30 and the y image coordinate is negative 30. So that's in the get pixel. So when we do the row, row starts at 0. So that's new row 0 minus trim size. Oh, it's actually not, it's not minus. We actually have to go plus, right? Because we want the source row is not going to be negative. It's actually going to be plus. Should have thought about that. So when we copy row 0 here, we want row 30. So we have to add 30. Okay, so let's try running that. All right, is that the right image? It looks correct on the left-hand side, but I think it's sticking out too much. I think we didn't trim the image enough on the right-hand side, right? So what's the problem there? Well, we trimmed the width by the trim size, but we have to trim it on both sides. So we want to multiply that by 2. Ah, there we go. You can see it in the background there. That looks like the correct trim. Okay, so what did we have to do here and what did we learn? So we built upon what we did on our first problem. We still had the same looping over the rows and the columns. We made the one slight improvement that we don't calculate the row offset until we only do it once per row. And then basically the same code about getting a pixel. But the new thing here is we've now set a pixel. So we set the pixel by getting the source pixel and then setting that into the new pixel. So when you have a pixel, the last problem what we did is we set the R, G, and B. And you can always do that. But if you, and you could get a pixel in the new image. So this is, we got it from the original image. You could actually get the pixel from the new image. And if you want, you could do a new pixel.red equals source pixel.red. .green, .green, .blue, .blue. Set each of those 3. But what would happen if I tried to actually set the destination pixel equals the source pixel? Nothing. And that may be a little bit confusing, and it actually should be confusing. Those of you who are more advanced can think about this being a pointer. And so if you're a C programmer, C# programmer, you know, it's a by reference. Or in C, it's the ampersand of it's taking the address, and so you need to actually, tell the compiler, the C or C# compiler, that you're copying the value and not just the address. But in Python, you can't do that. So if that went over your head, forget about it. Just pretend it never happened. But for those of you who understand other languages, that's the reason why you can't do that. What you really need to do is you either need to write a copy method, which is going to copy the information from one pixel to the other, or you can do like we did here. We have a set pixel method. Those are the 2 ways you can do it. Let's see, what else did we learn here? Oh, returning an image. Okay, so now we're returning an image, and again, exposing the man behind the curtain. When we return new image, this is it's a 190 pixel by 190 pixel image. That's actually pretty big in terms of data. We're not actually passing all of that data, copying it onto the stack and pulling it off somewhere else. We're just passing an address. So it's a pointer. Again, if that went over your head, don't worry about it. And so in order to do the add border, same kind of thing, but it's a little bit different. You have to figure out how to make the border black. So you can either do it by, specifically going over those pixels, or, the inefficient but simple thing is just black the entire image first. So I want to take a few minutes and show you what your assignment is this week and how it might, what have we done so far that applies to that. So the first one is code and place filter. So very similar in that you've got an image, you're not creating a new image, you're simply going to go through each pixel here, and you're going to affect the R, G, and B values. So that's actually very similar to the first problem that we did in section. Second one is finding forest flames. So there's a calculation for, again, the average brightness. And if that average brightness exceeds a certain threshold, then they actually, let me think for a second. Is this different than the average brightness that we just did? I think it's the same. It's the same brightness. But if it exceeds a certain value that they've flagged here, then you're going to turn that pixel red. And as you might imagine, you're just going to set the red value to be max and turn the green, the blue values off. And for any other pixel, you are going to make it gray by, let's see, grayscale, summing its red, green, and blue, and divided by the 3, find the average, and then setting each of the R, G, and B to this same average value. So that's good. Let me just verify the sufficiently red pixels. And sufficiently red is, its red value is greater than the average. Okay, so if the red value is greater than the average, and the last one we did is we took we calculated the average for all red, green, blue, and then decided to do something. Now we're only going to take a look at the red. So if the red is sufficiently red, intensity threshold, sufficiently red if its red value is greater than or equal to the average of the 3 values. So that still seems kind of weird. All right, I remembered what was confusing me. What's confusing me is why is the intensity threshold 1.0? That is a multiplication factor. It really shouldn't be called threshold. That should be the factor. So what you have to do is you have to average the value of the R, G, and B pixels, this here, and if that value times the intensity, if the red value is greater than the average multiplied by this factor. Okay, so it sounds a little bit complex, but it does work. Trust me, I've done it. So if it exceeds that, then you're going to set the pixel to be red. Otherwise, you're going to set the rest of the pixels to an average. So how does that compare to the little dog image? It's very similar, actually. It's slightly different calculation, but instead of looking at the average threshold, you're looking for the red. And instead of leaving all the other pixels, you're actually setting all the pixels to the average. So similar with those two changes. Now the other ones are optional, but I'll tell you a few, give you a few hints about these. So here what we want to do is we want to create a new image that is twice as tall. So we already know how to create an image that's different size. So this one's just going to be twice as tall. But the trick is that we want to copy the image on the bottom half flipped. And so again, let's talk about this. Are you going to be able to use a for each loop? No, because you need to know what the rows and columns are for these to be able to put them in there. And ideally, you want to use functions because copying all those pixels, obviously, if you copy the top half and the bottom half, well, there's a lot of common code in copying the top half and the bottom half. The difference is whether it's flipped. So you might want to think about having an argument to that function as to whether it's flipped or not. And if it's flipped, then you know that instead of starting at 0, 0 up here, you're actually going to be starting at the image's height, either divided by 2 or subtracting off the first height. So you start in the middle, and you're going to have to figure out how to reverse. You shouldn't think about it as reversing the order in which you're iterating the picture, but rather think about it as calculating the row where you're trying to set the pixel as being calculated, right? Instead of it being row 0, 1, 2, 3, 4, now it's going to be row 100, 99, 98, 97. So obviously you need to be subtracting something to flip that row number around. So think about that. But if you can do that as a function, that is going to really set you up for the next problem. So the next problem is, before we just had copying it in 2 places, top and bottom. Now there's 6 different places, and again, you shouldn't really hard code it for 6. But there's multiple different places that you're going to copy this photo, and you're going to copy it with a different shade. So you're going to multiply the red, green, and blue by certain numbers. For example, here's 1.5 for the red, and they're going to turn off the green and multiply the blue by 1.5. So if you can take that function that you just wrote, and instead of making it just a simple, it's either the top or the bottom, but instead have some arguments that tell it where to put this image, and think about what that argument should be. Is that a single argument? It's possible to do as a single argument, or do you want to have maybe two arguments? And what would those two arguments be? So tell that function where you want to put it. And then also, what is the scaling factor? Okay, these three things here, those are the scaling factor. So if you can have a function that does that, then you're going to be golden. So think about that. All right, well, it's been 50 minutes. So once you've done learned the stuff that's in the section, it should be enough to know how to do these other ones. Let's see, what other things are important here? Let me take a quick look. I wanted to say a note about debugging. So this becomes trickier to debug because we now have a 200 by 200 image. So that's about 40,000 pixels. So that's way too much to print out. You actually can print out, and I'll show you. Let me just print right here. I'll print column and row. Let's just run it. Oh, sorry. I guess I could print source call. So let's say you wanted, you're used to printing debugging, and you want to, come on, what is it? Oh, new row, new column. If you're used to debugging, you're used to by printing, so you're going to print out. So you can see it's going to print out a lot of these things. Eventually, it says too much output. So there's actually a limit on the number of things you can print. It still could be useful if you just want to verify, gee, is this thing doing the right thing? So you can, oh, it looks like it actually scrolled off the top. Yeah, it did. If I run it again and immediately stop it, you can scroll back up. So you see we started at row 0, column 0. Now, actually, I'm printing the X first. So it's printing column 0, column 1, column 2, all in row 0. Then once we get all the way down to, what is it, to 127. When we get all the way down to 127, then we start over. And now we're looking at row 1. Okay, so it's possible to print some things, but it's not really useful because you can't see the entire image. So how else can you debug? I think so normally in an IDE, you could step through the code, but you can't do that here. You'd have to install PyCharm to do that. I don't really recommend you do that. What I recommend is to draw out a very simple map. So for example, this image here, I would take a piece of paper and write down, okay, so you got 0, 0 up here. Let's say it's 100 pixels wide by 100 pixels tall, just for round numbers. So you go 0, 0 to 100 to 100, and this image here, we know it's 30 pixels less. So now it's 0, 0 to 70, 70. And just like I was showing earlier you think, okay, pixel 0, 0 here corresponds to pixel 30, 30 here. And once you start writing those things down, then you can see what are the differences in pixels that you want. And you can go ahead and print a few statements if you want, just to verify that it's doing what you think that you want it to do. Also, whenever possible, you know how at the very beginning I showed you, okay, well let's just create a new item and print it out. Now let's change it all to black, and now let's try to draw a row. Let's try to draw a column. Don't be afraid to experiment to verify that you know what's going on here. Those are simple ways that you can debug. When I was playing through the examples, I actually had that problem where I tried to assign the new pixel to the old pixel and it didn't work. And then I started playing around with doing those kind of things until I figured out, oh yeah, it's not doing that. I have to set the R, G, and the B done individually. So those are things that I would recommend in helping to debug these problems as you go through. Also remember, you can upload your own images. So a 200 by 200 image is fairly tough to work with, but there's no reason that you can't in Paint. Well, can you really draw a 30 by 30 image, that may be tricky. I'm not so well. You can save an image as 30 by 30, or even better. I thought about this. You can go ahead and create your own simple image, 30 by 30, and fill it in. Make it all black. Make it all white. Make it go from white to black. That's a simple image to deal with then, rather than the very complex images that we're dealing with here. So that's another idea for you. So hopefully you found this video helpful. If you did, please like and subscribe. That helps other people find these videos. And so we've got one more section, and then after that, they're going to be many of you are going to be wondering, well, what can I do now? Unfortunately, I don't have a full Python course for you, but I do have a full Java course. It's actually a 2-semester course that I teach for community colleges, and I've done it for many years, so I've gotten pretty good at it. So if you're interested, go to my channel for Mighty CS Man and look for the playlists, and you can see I actually use a book, and you can follow. You should get a copy of the book, and you can just search by chapter. Look for the lectures, and you can look for some problems, and yeah, it's a whole course. So that's an option for you if you want to continue your education. Thank you very much.